Hi, Mr. Crane here again for the third time today. So today we're going over Electromagnet Lesson 2. I've heard a lot of students send messages to me saying, hey, Mr. Crane, I don't have an electromagnet, I don't have a battery, I don't have wire, I don't have a compass. And I want you to know that for your virtual lab, you don't have to have those things. I'm going to provide those options for you. So if you go into your particular assignment, and the assignment is Electromagnets Lesson 3. It'll have this little designator 2.2 right here. It says, first thing is describe your observations of a compass near the electric circuit before and after there was current flowing in it. So where can you go to observe that? Well, guess what? I have left you a nice, wonderful PFET simulator. It says right here, this is an alternative to students who are at home virtually taking this class. Click on the link below. It will take you to a simulator of an electromagnetic tool or electromagnet tool. Use the simulator to answer your questions. It says, watch the class session part 2. 2 parts directly after the simulator to help you answer your questions. You can use the objects you see, the interactions between the electromagnet, the magnet, and the compass with objects around the classroom to answer your questions. Here's the link for the PFET website. It will look like this right here when you get to it. You'll have to wait because I don't think it's an HTML5 patch, software patch. So you'll have to wait for it to load. When it does load, it'll look like this right here. And when you open it, it has 2 tabs. One says bar magnet and one says electromagnet. You can change the polarity. That means changing the north and the south. So if you do that right there, that flips you north and the south, and all those little fields inside there switch. You can change the strength from 0% to 100%. When you change that to 0%, obviously there's no field around it. When you change it to 75%, oops, let me just drag that across, put it back at 75% roughly. All right, there's 75%. You can do it to 100, I don't care. But you can uncheck this and you won't see a field at all, but we want to see that field. We want to see here. We can even see inside the magnet. It shows domains lined up inside the magnets. Remember, an object is not attracted to a magnet or not magnetic if it does not have domains that are aligned. So those little plus and minuses or those north and souths in there, it's not going to be aligned. So you can see that by hitting that button right there. All right, so there's a couple other options there. You can show your field meter and you can show planet Earth. There's planet Earth. Let's show planet Earth right there. And again, look at that. It is a south at the North Pole, north at the South Pole. Crazy, huh? All right, so that's actually a snapshot you could use for Electromagnet Lesson 1. All right, I'm going to get rid of the field lines. I have somebody coming into class real quick to show me a bow. I'll show it to you too since we're looking at it. Oh my gosh, they got it all together. Check that out. That's 3D printed. That's amazing. See, that's why you should be at school, not at home.
No 3D printers at home.
No 3D printers at home. I know this is Coach Tucker and Coach Jens's and their class's creation. That is amazing. The cams work. The little counterbalance in the front works. It has a little whisker biscuit to set the arrow in. That is amazing. And they're going to have a little peephole sight when they put the string on it too.
We got the string. We're about to trying to figure that out right now.
And they're partnering with Southtown Sporting Goods on on setting the string. So that's pretty amazing. So see, that's why you should be at school. That's awesome, man. That's phenomenal.
That didn't bother.
No, you're good. I enjoy it. All right, so so you have all these fields that you can use, but you're on a lesson for electromagnets. So if you switch over this tab right at the top to an electromagnet, now you see that we have options like show field, show compass, show field meter, and show electrons, which I like the electron flow. These are electrons going through a wire. So we have a little battery. This is what the students are going to do in the class. They're going to take a battery, they're going to put a wire around it, wrap it around an iron rod, which is like a nail, and generate a magnetic field and create an electromagnet for themselves. So how can you use this to answer your question? So let's go to the question 1. So describe your observation of the compass near the electric circuit before and after there's current. All right, so let's go back to it, and we're going to turn the current off. Let's see. So if I take this battery up here, and right now it's set to 10 volts, if I run it across here to off, which that's in the 0 voltage, let's find zero voltage right there. No current flowing. What do you notice about the magnetic field? So if I move this around, the point end of a battery is the plus end, and a plus, there's no change in the compass. Do you notice that? So there's no change in how the compass is interacting. But I'm going to put this at the plus end. And the plus end is usually our north end of a battery. And we know that this red is the plus end or the north end of the compass. I'm going to turn this on, and what do we get? So we get the south end of the compass is now pointing towards the north end of the battery. If I move it over here, the north end of the compass is now facing, sorry, it's lagging a little bit, so it's not dragging correct. Maybe it's attached. That's funny. I think my compass got stuck in my magnet. Let's reset. Reset all. Yes, reset all settings. All right, we're going to hit play so that the electrons start to flow. When I move my compass over here, my plus end is facing my south end of my battery. So you can answer that question for your first question. Describe your observations of the compass near the electric circuit before and after there is current flowing on it. So turn the power on, see what is going on, turn it off, see what's going on. What happens to the compass needle placed around the coil of the wire when the switch was thrown on, starting the current flowing in the circuit? Draw what you see. Well, we just did that. And you don't have to draw what you see. You can just move your compass here. I know that this is the south end of my battery. That's the north end of my compass. I can hit pause it. You can take a snapshot. I'll show you how. So on your computer, you have Control Shift, and there's a little symbol at the top of your F1 through F12 keys. Right in the center is a little, like this little square. If you hit Control Shift and that little square at the same time, it will do this. So if I'm going to hit for Windows, I'm going to hit the Windows key, Shift, and my S, and it blackens everything, darkens it up. Now you have a mouse that you can move. I can hold my finger on my mouse pad, drag over it. You can also do print screen if you would like, and do a snapshot of your screen. That is going to hold my position. I'm going to come in here to my assignment. I'm going to hit Control V or right click and hit paste. I can do Control V or I can hit right click and hit paste. And that puts my symbol right there. So that's actually in the wrong place. Let me get rid of that. So we were on question 2. Sorry about that. So draw what I see. So, but don't forget, you have to describe it, not just draw it. What happens to the compass needle placed around the coil of the wire when the switch is thrown? So what happens when the power is going? The battery negative end is attracted to the positive or north end of your compass. If I move that over to the other side, you can see what happens over there. Does the coil of wire attract paper clips like a magnet does? Well, I just told you this is a magnetic field. Do you think it would attract magnets or attract paper clips? Well, it attracts paper clips with a normal magnet, and the difference between a normal magnet and a electromagnet is called a temporary magnet. So because we can turn it on or off, as you can see right there, we can turn it on or off. Permanent magnets, like this magnet I'm showing you right here, you cannot turn it on or off. It's always working. It's always attracting to metal. I don't know if I have anything that's not metal. Let's see if my cup is. That's not metal. I don't have anything here that's metal. Oh, I do too. I have a paper clip right here. Let me get you that. So here we go. So I can't turn that off though. I can't say magnet turn off and it falls. So a electromagnet, I can turn the switch off and it will fall. So just letting you know, that's what's going on. Does it attract? That should be an easy answer. What happens when the coil is placed on a magnet and then the electricity is turned off? What happens when the coil is placed on a magnet and then the electricity is turned off? So if we turn the electricity off in this particular setting, I'll turn that to there. And if I put a magnet inside that coil, magnets and magnets and electromagnets and electricity are inversely related. So if I put a magnet inside the coil, it will generate electricity. If I put a coil and wrap it around an iron piece and turn the electricity on, it will create a magnet. So one will make the other. So put a magnet inside a coil, it will create electricity. It'll induce a current. And if I do the opposite, then it will create a magnet. So an example of this is at dams where you have water flowing over something that's turning, a wheel that's turning. And if I put a magnet in the center of that and it starts turning around the magnet, water's pushing this wheel and it's turning around this magnet and there's coils over here. When it does that, it makes electricity, and that's actually what powers your house. That's an hydroelectric power dam. So that's how that works. How are magnets and coils of electric current alike and different? So I think I just explained that. If you didn't understand that, rewind it and listen to what I say, and I think you can answer that. So I hope that was helpful. Good luck. Play with the simulator. Simulator's kind of fun. Turn it on. Generate your power. You can, so if I turn it this way, you notice that the electrons inside the coil move. Let's look at that real quick. So I'm looking at the current. So the current is going this way, and I'm using my right hand rule. So the current's going, sorry, it's going, so it's the left hand rule. Right hand rule, left hand rule. I'm looking. So the current is going from the plus to the minus. That's right. So it's going from the plus to the minus, like that. And the coil is going in using my right hand, so it's going in. When I change my direction of my current, when I change the direction of my current this way, now it's going this way. So I'm going from my negative to my positive. Going from my negative to my positive. Now it's going out away from me. So kind of cool. All right. Hope that was helpful. Have a good one. Happy Thanksgiving.